Hi guys, welcome back to the channel Tech Concepts with Umei. In our last video, we covered some important keywords that help us to generate specific queries. Particularly, we looked at the like keyword, which as was indicated, is used alongside wildcards. We also looked at the order by keyword as well as the limit keyword. We ended the video by demonstrating how aggregate functions are used. We talked about 4 aggregate functions, which included sum, maximum, minimum, and average. Before I go any further, I would like to request that you subscribe to the channel. If you look at the bottom right of the viewport of this video, you will see a red subscription watermark. If you take your mouse and hover around that red subscription watermark, the subscribe button will appear. Please do well to subscribe. We will begin this video by looking at the last aggregate function, which is called the count function. The count function is used to count the number of rows that match a specified condition. For instance, if I wanted to determine the number of distinct rows that I have in a table, I would use the count function. Or if I wanted to determine from a list of employees the exact numbers attached to specific departments, then I would use the count function. We would look at some of these examples. We'll then explore join queries, which are useful commands that help us to visualize data across multiple tables with the addition of our key values. Obviously, we have talked about the addition of our primary key and foreign key values during table creation processes. So thanks to these keys, we have the opportunity to combine our tables to derive comprehensive views of data stored across multiple tables. For instance, we may have 2 tables labeled students and courses. Now, from these 2 tables, obviously, if we were carrying out queries for our student table, we will not get attributes from the course table. And in like manner, if we were carrying out queries for the course table, we will not get attributes of the student table. We may decide, however, to perform a query that adds course name. As you can see, course name is in the course table, but we want to add course name to some attributes from the student table. All right. Now, SQL allows us to do this based on the key values that we have in each of our tables. So if we wanted a new result set, okay, where we have student name, course ID, which obviously come from the student table, and then course name, which comes from the course table, we will have to perform a join query. And with postgreSQL, all right, the join keyword allows us to do this. Now, we have various types of joins, and these include the inner join, the left outer join, the right outer join, the full outer join, and then the cross join. However, for demonstration's sake, we will focus on our inner join. Now, our inner join returns records that have matching values in both tables. We will use this for demonstration because it is the most common use case of joins. For instance, for many business scenarios, pulling orders related to customers only makes sense if there is an actual customer related to specific orders or to a specific order, so to say. Now, if you would like to learn about the other joins, okay, so the left outer join, the right outer join, the full outer join, and the cross join, okay, there's a link in the description section to an appropriate web resource that covers this. All right. So without any further waste of time, we're going to get right into our practical um, session. So I'm going to navigate to command prompt, and then you will be expected to log in. All right. Now, we will use the count function to determine the number of rows that we have in the customer table. So I presume you have your 4 tables, created and populated. If you haven't done that, please refer to previous videos, that enable you or provide you with, knowledge of how to do this. Now, to achieve this, the command we had just stated, the count function to determine the number of rows that we have in the customer table, all right, we will write a query that looks as follows. We're going to say select, okay, we're going to use the keyword count, select count, open parenthesis, all, so we're counting all from, okay, and then we're going to say customer, and then I'm going to end with and I'm going to hit the enter key, and you will see that for our customer table, we have 51 rows. Okay, so that helps us to determine how many rows we have in our tables. Now, we may also count the number of rows that meet a specific criteria. For instance, we may want to count the number of rows holding customer information for people who earn above, a monthly income of 100,000, right? Now, to achieve this, we'll have a command that looks as follows. So here I'm going to say select, okay, again, counts, and then we're still going to say all from, okay, customer, and then we're going to say where monthly income, which is one of our attributes, okay, where monthly income is greater than 100,000. Okay, I'm going to, all right, add my semicolon, all right, add my semicolon, and then I am going to hit the return, okay, and it tells us we have 20 rows that meet this criteria. It tells us that there are 20 rows that meet that criteria. Now, for our next example, we'll use the customer care assistant table. For our next example, we'll use the customer care assistant table, and we'll use it to demonstrate, the point we're trying to make in terms of how our count function will help us to categorize data. So we may want to determine the number of unique branch IDs represented in our customer care assistance table. All right. We may want to demonstrate, you know, categorization, okay, by determining the number of unique branch IDs represented in, our customer care assistance table. Now, to achieve this, we'll write out a command that looks as follows. So here we're going to say select counts distinct, okay? Select counts distinct branch ID. All right, select count distinct branch ID from customer care assistant, okay? And then I'm going to end with the semicolon. All right, and it tells us we have 3 distinct branch IDs, which means for each of the rows of, customer care assistants we have in the attribute column, all right, for each of these rows, an employee or a customer care assistant will fall into one of 3 branches. A customer care assistant will fall into one of 3 branches. Okay, now, as a final example of our count demonstration, we may want to group our rows into categories based on the entries of a specific attribute. For instance, for each of our customer care assistants, we may want to determine the number of customer care assistants that are part of each of our 3 branches. All right. Now, to achieve this, in addition to our counts keyword, we will also use a second keyword, which is termed group by. Here, we will group our counts into the number of distinctions we have for our branch ID attributes. Now, if we're supposed to do this, our command will look as follows. So here we're going to say select, okay, branch ID, which is one of our attributes in our customer care assistant table. And then we're going to say all, count all from table cost care assistant. And then we're going to say group by branch ID. Okay, so typically whatever you are selecting for a query like this, where you're trying to group your entries into, specific categories, whatever you're selecting by, typically you're going to group by. So keep that in mind. What you're selecting by, typically you will group by. So if I end with my semicolon and I hit the enter key, you will see that for our branch ID 202, we have 10 employees. For our branch ID 201, we have 10 employees that match that criteria. For our branch, ID 203, we have 10 employees that match that criteria as well. Now I'm going to do something so that it, brings better context to what we have just spoken about. I am going to say select all. Okay, let's do things as we have always done. All right, so for our SQL keywords, we use capital letters. Select all from customer care assistant. Okay, customer care assistant, and I hit the enter key. All right, so here you will see this is what our table looks like. And this is the attribute which we worked with for our count function. All right, you can see that BID, that's it. And you see that for each of our employees, you either fall into the branch with ID 201 or the branch with ID 202 or the branch with ID 203. Okay, so let's look at the entire table. You will fall into one of those categories: 201, 201, 203, 202, 203, 203, 202, 202, 203, 201, 201, 203, 203. So you can see that, right, for yourself. You do not have any other branch IDs, which is why we have the count here for branch 202. We have 10 employees, okay, that are parts of that branch. In like manner, for branch 201, we have 10 employees that are part of that branch. And for 203, we have 10 employees that are part of that branch. Okay, you can count it yourself if you have time after you have performed, the query. Now, next, we'll turn to our join query example. Okay, so as indicated, our join queries help us to visualize data across tables. Now here, I will use our customer table as well as our order table to demonstrate our example. Now, for customer insight purposes, I may want to view customers and the names of ordered items that they have purchased. Obviously, using only the customer table, I cannot get that information. Also, using only the order underscore tab table, which is our order table, I cannot get that view. So therefore, I need to combine both tables to get a result set with the holistic set of information that I need. Therefore, a join query will be required in this instance. Now, as indicated at the beginning, we will use the inner join to demonstrate our example, noting that if both tables have all cells populated, all right, as may be required in a similar real-life scenario, then this will be the most likely case. Okay, so that will be the most likely join we will use, where both tables have primary keys and foreign key connections. Also, all cells are populated. Then we will use the inner join. Now, to carry out the query that we have just specified that we'll carry out, okay, we'll use a command that looks as follows. Select, okay, name, age, telephone number, telephone number, and ordered item. Okay, from customer. Remember, our attribute selection is not coming from only one table. Our attribute selection is not coming from only one table, but two tables. So for instance, we have name, age, and telephone number coming from our customer table. And we have ordered item coming from the order underscore tab table. So we have to use an inner join or some other type of join. And we have demonstrated and we have indicated as well that we're going to be using the inner join. So from customer table, inner join. Okay. What table are we joining? Order underscore tab. On, we're going to use that as well. Okay. So what attributes from these two tables are connected is what we're going to specify with or after our on keyword. So here we're going to say customer dot BSSN, which is equals to order underscore tab dot CSSN. And then I'm going to end with my semicolon. I'm going to hit the enter key, and you will see we have 4 attributes, 3 coming from our customer table, and the last one coming from the order underscore tab table. And the reason we're able to do this is that we have used our inner join, keyword over here. All right. Just for further confirmation, I am going to do something here. I am going to say, okay, let's get to the end of this. Okay, let's get to the end of this. Mm, okay, let's get to the end of it. Right. Okay, so we have 101 rows. So keep in mind that some of our um customers have made multiple orders. Some of our customers have made multiple orders. So it's why you will see that their name appears multiple times. Okay, so um, that being said, I want to do something else. I want to show you that our customer table does not have the order item, attributes. So I'm going to say select all from customer. Select all from customer. Going to hit the enter key. And let's look at the attributes we have here. We have BSSN, which is what our key value is as far as the relationship between the customer table and the order underscore tab table is concerned. So we have BSSN, we have name, we have age, we have telephone number, we have monthly income, we have CCA ID, but we don't have anything that looks like ordered item here in our customer table, as you can see. But we're able to make that connection because we used an inner join, right? So let's do the same thing for our um, order table, which is represented as order underscore tab. So here I'm going to say select all from order underscore tab. Okay. And I'm going to hit the enter key, and you will see here nothing about customer names. Okay. Or their telephone numbers. We don't have any information like that here. Okay. Our join query, we have name, age, and telephone number. And our order table, all right, does not contain, any of that, information or those attributes. Okay. So just to demonstrate that point. Now, um, like I indicated, for demonstration of other join types, look at the description portion of this page, and you will see, a link that points to a web resource that adequately explains them. Now note, all of the keywords that we have used for demonstration, beginning from the first query video, all right, they don't have to be used in an isolated manner. We can decide to use them all together in one query to address, more complex questions that, we want result sets for. For instance, the clothing retail store may decide that they want to reward their most dedicated customers with gift vouchers. As such, we may want to present a result set that shows two columns. The first will contain names of customers, and the second may contain the number of ordered items that these customers have. Now, the person carrying out the query, all right, may also want a result set to be arranged in order of the person who has made the most number of orders. Okay. And then in that order to the last person, or the person who has made the least number of orders in this specified category. Now, to get the names of customers and the corresponding number of items they have ordered, we'll need to perform a query that requires data from two tables. Okay. And these will include the customer table and, again, the order tab table. Now, our query will look as follows. I'm going to scroll to the bottom of this. Okay. And then we're going to say select customer name. Okay. And I'm going to say count all. Select customer name counts all. I'm going to add, another keyword. We're going to call this as. Remember when we did our demonstration of count functions, I'm going to scroll up a little bit. When we had our demonstration of count functions, I will show you something in a second. Okay. Right. So with this query, so we wanted to find out all the customer care assistant, branch affiliations. So find out how many belong to branch with ID 202, branch with ID 201, and branch with ID 203. Now you note that in the result set, all right, the heading of this column is called count, which is this, because we're counting the number of our entries that fall into these different categories. All right. Now, what we want to do with our indication of the as keyword, or AS, is change this count name. All right. We may want to change the count name to something more appropriate. So as opposed to having count in the result set for this particular column, we're going to have the name that we desire. So I'm going to go back to the bottom where we are. Okay. I'm going to go back to the bottom where we are. And as you can see, we have started our count query again. And we're selecting, customer name, and we want to group by name as well. All right. So we want to see the number of orders associated with each customer. Essentially, that's what we want to do. So here we're saying select customer.name, count all, but we want to give that count, column an appropriate name. We want to give the count column an appropriate name. So we're going to say, let's call it items ordered. Items ordered. Or number. Maybe we could say number of items ordered. Num. So let's call that num. Number of items ordered. Okay, so that's how our count column is going to be labeled. And then we're going to say from customer, right? Again, we're going to use the inner join, order tab, order underscore tab, on, say on customer dot PSSN is equals to order underscore tab dot CSSN. Okay. And then we're going to use the group by, say group by, as I indicated, whatever you're selecting by, you group by. So we're going to say group by customer dot name, right? And then we're going to say order by, that's not how we spell order, order by items. So no, that's not, we're ordering by this column, okay? Which is our count column. So we want to order by number of items ordered. Order by number of items ordered. We can order in ascending or descending order. In this instance, we want descending order because we want to see the most to the least. Okay, so I'm going to end with my semicolon and I am going to hit the enter key and you will see, okay, each customer and their number of orders. Okay, starting from the highest order to the lowest. And you also see that as opposed to count, you know, being the heading of this column, we have number of items ordered. All right, just as we have indicated in our command. Okay, so you can play around with these examples and, variations of other queries that you may want to carry out. All right. So this brings us to the end of this video. Now in our final video on queries, we will talk about, some other keywords that support SQL queries with postgreSQL. Okay. So for instance, things like select distinct, the having keyword, the in keyword, then also look at, say a command that will enable us to update a column or update a particular entry, right, of records into, or entry of a record or multiple records in our PostgreSQL database. Okay, so that will be the last video on our query session, the next video. And after, we have done that last video, you will be able to, play around with, the select commands and the variations of keywords that you can use with the select command to carry out queries. We're not saying everything that would have been covered in terms of queries constitutes an exhaustive list or will constitute an exhaustive list of every query command with PostgreSQL, but it covers the fundamentals, which you can obviously build on if interested in learning, relational databases and how to query relational databases, to an advanced level. So thank you for tuning in again. Please do not forget to subscribe to the channel. I will see you in the next video.